Our world is rapidly becoming more connected. Devices, sensors, and systems are constantly generating data. This data holds incredible potential, but traditional cloud computing models often fall short. Enter edge computing, a transformative approach that's changing how we process and act on information. Edge computing brings computation closer to where data is generated. Instead of sending data to a distant data center, edge computing processes it locally on devices or nearby edge servers. This shift in paradigm unlocks faster insights, improved efficiency, and new possibilities for real-time applications. Edge computing is revolutionizing industries like healthcare, manufacturing, and transportation. It's driving innovation in areas like autonomous vehicles, smart cities, and personalized experiences. As the volume of data continues to explode, edge computing will play an increasingly vital role in our increasingly connected world. Imagine a self-driving car. To navigate safely, it needs to process massive amounts of data from sensors in real time. This is where edge computing comes in. Instead of sending all this data to the cloud, edge computing allows the car to process it instantly on board. Edge computing architecture typically involves 3 layers. The device layer includes sensors, cameras, and other data sources. The edge layer consists of edge servers or gateways that process data locally. Finally, the cloud layer provides centralized storage and analytics for long-term insights. This distributed approach offers several advantages. By processing data closer to the source, edge computing reduces latency, improves response times, and enhances real-time decision-making. It also minimizes bandwidth requirements and reduces the load on central cloud infrastructure. The Internet of Things, or IoT, is built on the idea of interconnected devices. Sensors, actuators, and other devices collect and exchange data, creating a network of intelligent objects. Edge computing is essential for unlocking the full potential of IoT. Consider a smart factory. Sensors on machines collect data on performance, temperature, and other parameters. Edge computing enables real-time analysis of this data, allowing for predictive maintenance, optimized operations, and improved efficiency. Edge computing also enhances security and privacy in IoT environments. By processing sensitive data locally, it minimizes the risk of data breaches during transmission to the cloud. This is particularly important for applications involving personal or mission-critical information. Section 4. Edge versus Cloud. Understanding the key differences. While edge computing and cloud computing are often mentioned together, they serve distinct purposes. Cloud computing excels at handling large-scale data storage, processing, and analytics. Edge computing, on the other hand, focuses on real-time data processing and decision-making at the network's edge. One key difference lies in their latency. Cloud computing, due to data travel distances, can experience delays. Edge computing minimizes latency by processing data locally. This is critical for applications requiring instantaneous responses such as autonomous vehicles or industrial automation. Another difference is in their bandwidth requirements. Edge computing reduces the amount of data transmitted to the cloud, saving bandwidth and costs. This is particularly beneficial in remote locations or areas with limited connectivity. Section 5. Edge computing in action, transforming industries. Edge computing is transforming industries across the board. In healthcare, it's enabling remote patient monitoring, real-time diagnostics, and improved medical imaging analysis. Doctors can access patient data instantly, leading to faster diagnoses and more personalized treatments. Manufacturing is another sector reaping the benefits of edge computing. Factories are using edge devices to monitor equipment performance, predict maintenance needs, and optimize production processes in real time. This leads to reduced downtime, increased efficiency, and improved product quality. Transportation is also being revolutionized by edge computing. Autonomous vehicles rely on edge computing to process sensor data and make split-second decisions. Traffic management systems use edge devices to optimize traffic flow and reduce congestion. Section 6. Real-world success, edge computing case studies. Numerous companies are already leveraging edge computing to achieve remarkable results. For example, a leading automotive manufacturer implemented an edge computing solution to improve its assembly line efficiency. By analyzing data from sensors in real time, they were able to identify bottlenecks and optimize production processes, resulting in a significant increase in output. Another compelling case study comes from the energy sector. An oil and gas company deployed edge devices on their offshore platforms to monitor equipment performance and predict maintenance needs. This proactive approach helped them reduce downtime, prevent costly repairs, and improve worker safety. These examples highlight the tangible benefits of edge computing in real-world scenarios. As the technology continues to evolve, we can expect to see even more innovative applications and success stories across various sectors. For more videos like this, subscribe, like, and share. Thank you.